Welcome to a new type of video. Now this is one where you send in your questions and I'm answering them. Questions about mathematics. So let's get started. So there's been someone in year 4 whose name begins with L asking about telling the time questions. So I'm going to go through telling the time. So we're going to need a clock for that. Here's our clock. So there's 3 hands on the clock, the green one, orange one and the thin blue one. We're not going to worry about the thin blue one, that's the seconds hand. You don't really need that to tell the time. You need to worry about the short orange one and the long green one. They're not normally orange and green on a clock, are they? Just this one. The short hand and the long hand. Now the short hand is the hour hand. That's the one you want to look at first. So the hours are written on a clock. You start at the top and you go clockwise. This way around, that is. Clockwise is this way around. So you always look at the clock this way around. So I start at the top and I see that the orange, the short hand, the hour hand has gone past 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's gone past 10, hasn't it? It's just gone past 10. So the time's got something to do with 10. So get your hours sorted out first. That's what I would say. Go straight to the short hand, see what it's gone past. It's gone past 10. So the time's going to be 10 something. Let's write that back. And then after you've got the hours, you just look at the minutes. Now for the minutes, you're going to need the invisible 5 times table, which is not written on clocks normally. So 0 at the top. I know you know your 5 times tables though. 5, 10, 15, 20. The invisible 5 times table goes around the outside of the clock and that tells you your minutes. So while you're practicing, you could write that on any clocks you've got to practice on. This is the minutes, but they're not written on, only the hours are written on. So the minutes go like this. The green long hand is the minutes. How many minutes is it pointing to? Well, we go 5, 10. That would be this big chunk here. We've got one more than that. We've got 11. 11 minutes. So it's 10, 11. We know it's 11 minutes. We could count every separate minute, couldn't we? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we know it's 11 minutes. So the time is 10, 11. The digital time, this one, is 10, 11. Let's look at another time. Practice is what makes you better. So when we go to these clocks, don't worry about the second hand. First of all, do the hour hand. It starts at the top and it's gone round. What's it gone past? It's gone past 1, 2, 3, 4, 5. It hasn't gone past 6 yet, has it? 'Cause it's pointing about here. It's gone past 5. So it's 5 something. So always go to that short hand first and get your hours sorted. Then you've got a good idea what the time is anyway when you know it's 5 something. Next we're going to do our minutes. Let's rub these off. We're going to do our minutes now. Minutes is this long hand, the green hand, and I can sing my 5 times table. 5, 10, 15, 20, 25, 30, 35. So that's 7. 7 times 5 is 35. It's got 35 minutes round and then an extra 1. An extra little 1. It's gone 36 minutes round, so it's 5:36. I can't stress enough, get your hours sorted, then do the minutes. Let's do another one. Let's get the hours sorted. It's not gone very far, has it? The hours has just gone past 12, so it's 12 something. Then let's get the minutes sorted out. We need our invisible 5 times table for the long hand, the minutes. So we go 5, 10, 2 times 5 is 10, and then we've got 11, 12. 12:12 is actually the time. The hour has gone past 12 and the minutes is on 12. 12:12 is the time. Hours, then minutes. So hours first, so shorthand first. That's pointed directly at 6. These ones can be a bit tricky if you can't quite see if it's before 6 or after 6. I think this one is slightly after 6, just slightly. Anyway, it's going to be 6 on the hours. What's it going to be on the minutes? Not much, because the long hand, starting from the top, hasn't even gone 5 minutes, has it? It's not even gone 5 minutes yet, so we can't count it 5s. We'll count the little ones. 1, 2. It's just gone 2. The time is 6 o'clock and 2 minutes. We write that like this. 6:02. 6:02. So if it's only 2 minutes, it's 02. 3 minutes is 03. 4 minutes is 04. 9 minutes is 09. It's only when you get to 10 minutes that it'll be 6:10. So this time is 6:02. Let's try the next one. This is quite a tricky one. Let's do the hours first. Always the hours first. What's the hours on? It's gone past 1, 2, 3, 4. You might think it's pointing to 5, but actually it hasn't gone past 5 yet. It's just near to 5. So it's actually only gone past 4. This happens when the minutes is quite near to the top. When you get the minutes hand quite near to the top, it might be difficult to see if it's gone past the hour or not. This hasn't gone past the 5. It's only 1, 2, 3. It's 4 something. It is nearly 5 o'clock. So what is it? 4 on the hours. It's going to be 4:50 something, I'd say, because it's nearly 5 o'clock. So I'll get blue to do my 5 times table. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. And then there's a couple of extra ones. 51, 52. 4:52. If you can't tell the time very well, what you need is practice. Simple as that. So let's get some practice by going to this interactive clock on the internet. If your parents let you use the internet, you can go to this site. I won't press the link here. I'll show you how to find it on Google. Ask your parents if you can go onto this interactive clock. You go onto Google, you type interactive clock. You can copy the spelling from me here. Interactive clock, and it should be the first thing that comes up. Looks just like the one we've been using. You can do all kinds of little options here. I'm going to turn the time off. I'm going to turn the time off, and I'm going to set a random time. Continue doing what we were just doing. So hours first. What's the hours gone past? Starting from the top and going round, it's gone past 10. So it's 10 something. About the minutes. So the long hand, you do your minutes in 5s. 5, 10, 15, 20, 25, 30, 35, 40. Can't do any more. So 8 times 5 is 40 minutes. 41, 42, 43. So 10 on the hours, 43 on the minutes. Let's check that. 10:43. Even does the seconds on this time. You do not have to tell the time with seconds at this stage. You're just trying to tell the time. 10:43, the digital time. Let's do one more. We'll do hours first. Hours has gone a long way round. It looks like it might be 12, but it's actually before 12. So it's 11 something. And let's do the minutes. 5, 10, 15, 20, 25, 30, 35, 40, 45, 46, 47. It's between 47 and 48. Let's say 48 this time. 11:48. Let's check that. Oh, it's 11:47. That doesn't make me look very good, does it? That's because, as I said, it was between 11:47 and 11:48. So it's 11:47 and 39 seconds. But you don't need the seconds. If you saw this time like this and you said 11:47, that would basically be right. And if you said 11:48, that would basically be right. Because you don't have to get it exact between those 2 minutes. It's 11:47, I suppose, very nearly 11:48. Yeah, so practice this. It's right here on the internet. Practice will make you better at telling the time. Next, let's have a look at another option of practicing the time in the form of a game. It's this website, Teaching Time. So again, you can go to Google. If your parents allow you to, you can type in Teaching Time. First thing that comes up, Teaching Time. Now this you could buy for $2.99, but you don't have to buy it. You can evaluate it, which means test it. They're very happy for you to evaluate it. So if you go down, you'll see Evaluate. And you can practice that game. But, well, it's actually a whole class clock. But these are the games that lots of you have played in school and like playing. A very good year is year 4. Whatever year you're in, if you're trying to learn to tell the time, year 4 is the real best game for this, I would say. So this stop the clock game is pretty good. You press year 4 and it lets you evaluate this game. You might have to get your parents to make Flash Player work or whatever. But here it is. You have to spot all these times, match them up and get the fastest time you can. So I'm going to carry on telling the time just like I was in the examples. This time the short red hand is the hours and always the long hand is the minutes. There's no seconds on these ones even. So this short red hand looks like it's on 10. I think it's actually a tiny bit before 10. So I think it's going to be 9:50 something. Let's check the minutes. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 56, 57, 58. I think it's 9:58. There it is, 9:58. Next one, red hand. The short hand first. Always short hand first. It's gone past the 7. So it's 7 something. It's going to be 7:28 because there's only one 7. 5, 10, 15, 20, 25, 26, 27, 28. 7:28. Next one, it's one of these ones where the minutes is close to the top. So it looks like 3. These are the hardest ones, but it's actually going to be 2 something. It's actually 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 56, 57, 58, 258. Very similar to the next one, which is almost exactly the same, which is 256. And then 6:33, because the hours has gone past the 6, the red hand's gone past the 6, and the minutes is 5, 10, 15, 20, 25, 30, 31, 32, 33. Minutes is always a 5 times table. As you can see, 1 minute 22. I'm sure you can get a lot faster than that. I know there were some children in year 5 who were practicing this at lunchtimes and got incredibly fast. So have a go at teaching time on the internet. That's a lot of fun, and it will help you learn the time. That's it for telling the time. Now just a few time problems. So I'm going to answer these. Write the time in digital time. That is what we've just been doing. That's what we've been doing the whole time. First of all, go for the hours. Always hours first. What's this hours? It looks like it's gone past 10, or it might not have. I think it's just gone past 10. We'll check with the minutes. So the hours is 10 something. The minutes is 5, 10, 11. 10, 11. Write the time in digital time. Write the time in digital time is 10, 11. Next one. This clock is 10 minutes slow. Write the correct time in digital form. Use AM or PM. Well, it's morning. Morning is going to be AM. So I know it's going to be AM, whatever it says, because morning is AM. This clock is 10 minutes slow. Write the correct time in digital time. So first of all, you need to find what the clock says. Hours first, always. What's the hours gone past? It's gone past the 5. Starts at the top, doesn't it? It's gone past the 5. So it's 5 something. I'm going to write what the clock says first, and then worry about the 10 minutes slow bit. I'll worry about that at the end. So it says 5, and then the minutes, the long hand, 5 times table for the minutes. 0 at the top, 5, 10, 15, 20, 25, 30, 35, and one more, 36. The clock says 36. This clock is 10 minutes slow. If the clock's slow, the real time is faster than that. The real time's ahead of that. It's going to be 5:46, isn't it? 5:36 plus 10 minutes. 5:46 AM, we said. This clock is 10 minutes slow. Write the correct time in digital form. It is 5:46 AM. It says 5:36 AM, but it's slow, so it's really should be further on, and it should be 5:46 AM. Next one. This clock is 15 minutes fast. Write the correct time in digital form. Use AM or PM. Afternoon is PM, so it's going to be PM. Let's get the hours first. It's gone past the 12, hasn't it? That's all it's gone past, 12 something. And the minutes, 5, 10, 11, 12. It says 12 PM, but this clock is 15 minutes fast. So really we have to rewind 15 minutes. If we rewinded 12 minutes, it would be 12 o'clock, wouldn't it? But we've only rewinded 12 minutes. We're supposed to rewind 15 minutes, so we're going to have to rewind 3 more. So it's not 11:97, because time is out of 60, isn't it? It's 11:57. This is very difficult, right? Because if it says, the clock says 12 in the afternoon, but you go back 15 minutes, you actually go back to the morning. That's why this is a very tricky question. This clock is 15 minutes fast. Write the correct time in digital form. It says 12 in the afternoon, but you rewind 15 minutes because this clock is fast, and it's 11:57 in the morning. So the answer is 11:57 AM. That's a trick question, that one. On to the next one. How many complete turns will the minute hand make until the clock shows 9:02? What does the clock show? Hour hand first, short hand first. Looks like 6. Looks like it's on 6. It could be just before. But as the minutes is only 2, I think it is 6:02 is what it says. How many complete turns to get 9:02? Well, 6. A complete turn's an hour. So 1 would take it to 7:02. Another turn would take it to 8:02. And another messy turn would take it to 9:02. So it's 3 turns for the minute hand, which is the long hand, which has to go all the way around to move the hour hand on another hour. Next one. This clock is 20 minutes slow. Write the correct time in digital form. Use AM or PM. So what does the clock say? Hours first. 1, 2, 3, 4. Hasn't gone past the 5 yet, has it? No. It's 4 something. It says use AM or PM. which we actually can't use because it doesn't tell us. So I have to cheat a bit. Well, I have to make up a bit more of the question and say that the clock is talking about the morning. So anyway, the hours was 4, the minutes 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 51, 52. It says 4:52. This clock is 20 minutes slow, which means the real time's ahead of that. So if you added 20 minutes, you would get 4:72, because 52 plus 20 is 72. But there's not a time called 4:72, because minutes is out of 60, isn't it? So in problems like this, best thing to do is get a little number line. So I go 4:52. I need to jump forward 20 minutes because this clock is slow. It should be 20 minutes forward. The real time is 20 minutes forward. 4.52. I'm going to jump up to the next hour, which is 5 o'clock. 52. Let's count in ones till we get to the hour. So 52, 53, 54, 55, 56, 57, 58, 59, 60. 8 minutes till we get to 60. And 4:60 is the same as 5 o'clock, isn't it? And then we need to add the rest of our 20 minutes. We've added 8. How many more do you have to add on? Well, 12, because 8 plus 12 is 20. That takes us to 5:12. So what is the real time? Write the correct time in digital form. The correct time is 5:12. It says use AM or PM. If it's the morning, it's AM. 5:12 AM. So the clock said 4:52, but it was slow. The real time was 5:12. Not easy, but with practice, you'll get better at them. Right, that's enough about time. Someone from Mrs. Armstrong's class asked for some extension work because they're finding the work quite easy that they've got at home. So Mr. Grew and myself talked about this fractions extension activity. So I've drawn a fraction wall on the board, and for this activity you'll need to draw yourself this fraction wall. You have to be very careful, make sure the halves are the same size as each other. It's quite difficult, I had difficulty drawing it on the computer. Make sure these halves are the same size as each other, half and half. You have to make sure all these quarters are the same size. I'd write a quarter on each one. So you basically build this. All of these are twelfths, because there's 12 of them. Twelfths. So it's like a little bit of art first, because if your parents allow you to cut, you're going to be drawing this fraction wall and cutting it out. So you've got all these little fractions. I could write 1/12 all the way across, couldn't I? But I don't need to do that for you. Thirds, these are called. It's easy to write on 3 of those. And the bottom, these are called sixths. I would advise you to write on every piece so you know what they're called. I'm not going to do it because it's a bit boring for you to watch. The top one is 1 whole, isn't it? What the activity is to build a fraction wall, cut it out like this, and then see how many combinations there are that make 1 whole. The top one is 1 whole. How many combinations are there that make a whole? We've got 1, 2, 3, 4, 5, 6 combinations that make a whole. The top combination would just be called 1 whole. The second one would be called a half plus a half. The third one would be called a quarter plus a quarter plus a quarter plus a quarter. The next one would be, you could write 4 quarters. Like that. The next one would be 12 twelfths. You could write 12 twelfths. Like that. How you record it is kind of up to you. But the point is to find different combinations to the one on the board. Different combinations that make 1 whole. So here's an idea. This one is not on the fractions board, on the fractions wall. This is a half and a quarter and a quarter. This is quite hard, this stuff. This is an extension activity, which means it's for people who find everything else easy. It's quite a lot of work, a lot of investigating with this. So half plus a quarter, that makes a whole. So you've found one new one. There's another one at the bottom. What's this one? This is a third plus 4 twelfths. That also makes a whole. And I warn you, if you do this extension activity, this is for people who are really doing well with their fractions. It's going to take a long time to find all of them. There's a lot of combinations that make 1 whole. And that would be your activity for W in Mrs. Armstrong's class. See how many combinations you can find that are not already on this fraction wall, and they make 1 whole one, the same size as this. And if you do want to do that and you send that in, Mr. Grew and myself will have a look at that and see if we can find any that you haven't found, because there is a lot. So there you go. That's for people in, well, it's very hard for year 3s, but that's for someone in year 3 who's really doing well with maths and wants an extension activity. Anyone who wants can do this, of course, if you're doing well with your fractions. Not easy though. If you're struggling with fractions, this is probably not for you. You can still have a go. Let's move on. What do we have next? Many year 5s say they are struggling with fractions. I was just talking about that. So if you're in year 5 or year 6, most year 6s are in school though. If you're in year 5 and you're struggling with fractions, which is common because we've heard from quite a few children about that, I would say the best thing to do is go to our YouTube playlist. It's called, and here it is, on the playlists for KS2 Maths at Home on YouTube. If your parents let you go on YouTube, or maybe they'll do it for you. You go onto YouTube, you get KS2 Maths at Home, go to the playlists. What you want for fractions if you're struggling is this year 3 and 4 fractions playlist. Please don't think because it says year 3 or 4 is too easy for you. Definitely not. If you're struggling with fractions, you're going to need this playlist. And there are 10 videos in here. The first 5 go through fractions with lots of pictures, lots of understanding about what fractions are. And that will really, really help you. If I teach fractions to year 5s or your 6s, or say I'm teaching a year 5 set, fractions, the first thing I do, I will teach them all the year 3 stuff, all the year 4 stuff, and then the year 5 stuff. So if you're struggling, you need that playlist. That will really, really help you. There's year 3 questions in the year 6 SATs, there's year 4 questions in the year 6 SATs, and there's year 5 questions in the year 6 SATs, okay? So learning things from before your year is not too easy. If you're struggling with fractions, you definitely need this playlist, okay? So I'd say watch the 5 videos. They're between 20 and 30 minutes long, and then the next 5 videos are just practice ones after that. That will really, really help you. If you do one of those videos, one a day, you could fix your fractions before you come back to school by watching one of those fractions video each day. I'll definitely advise that. Let's move on. A little bit of fractions here. This is harder than what's in those videos, okay? So I would definitely advise you, your first thing to do is go to those videos and watch them if you're struggling with fractions. If you want to know especially about converting fractions to decimals, as some people have asked, I'll show you how to do that now. So this fraction is a half. I've written a half, okay? A half, I don't know if you know this, but you should know this. This line means divide. So it means 1 divided by 2. That's what a half actually means. It means 1, the line means divide, and 2 at the bottom. So a half means 1 divided by 2. It's like you have 1 sweet, you share it between 2 people. You're going to get half of it each, aren't you? Because half means 1 shared between 2, 1 divided by 2. You can do 1 divided by 2 on the bus stop. This is not, by the way, this is not a year 3 level, this question, and it's not really a year 4 level. This is more year 5 and 6 level now, as I'm talking about fractions. So you do not need to know this in year 4, but for year 5s, this is for you. You can do 1 divided by 2 on the bus stop. It won't work very well. It won't really work at all. But if you make it 1.0 or 1.00, then it will work. So 2 into 1 is 0, carry the 1. 2 into 10 is 5. 2 into 0 is 0. You probably, that's supposed to be 0. You probably know that 0.5 is the same as 0.50. So I didn't actually need 2 decimal places. I could have done it with 1. So what we've got here is the answer of 0.5. That is the decimal that's worth a half. So we're talking about fractions to decimals. We've got fraction. You turn it into the decimal. You can do that on the bus stop. You might know, of course, that half is 0.5, but if not, you can turn a fraction into decimal using the bus stop. I'll show you another example. Next one is 1/3 that we're going to do. 1 divided by 3, that's what it means. I could write equals 1 divided by 3, but I think I'll just start over here by doing 1 divided by 3 on the bus stop. 1 divided by 3. To make it work, you need to put a point on, and then you can place some zeros, because 1.00 is worth the same as just 1. I personally like putting 2 decimal places on, but you could put 3 on, or 1 on, see what you need, really. We'll see what we need. How many 3's in 1? 0, carry the 1. How many 3's in 10? 3, 6, 9 is 3, carry the 1. How many 3's in 10? 3, 6, 9, 3, carry the 1. How many 3's in 10? 3, 6, 9, 3, carry the 1. This one goes on forever. It's called recurring when the number goes on forever. 0.333 recurring. So you can, there's different ways of writing it, but you can say 0.33, and you can do this little mark, which just means it's just going to go on forever. Those 3's are going to go on forever. It's nothing and a bit. You should know, of course, that fractions are just little bits of something, and decimals are little bits of something. So all these are less than 1. So 1/3 is less than 1, isn't it? And 0.33 is less than 1 because it doesn't have a 1 in the units column. You can change any fractions into decimals this way. 1/4 is 1 divided by 4. So let's do 1 divided by 4, see what we get. Won't work unless you do 1.00, which is the same as 1. 4 into 1 is 0, carry the 1. 4 into 10 is 2, carry the 2. 4 into 20, 4, 8, 12, 16, 20. That's 5, it works. 0.25. The decimal for a quarter is 0.25. I think this is an excellent little trick to know, that you can turn any decimal into a fraction. Sorry, I said that wrong, didn't I? You can turn any fraction into a decimal just by using the bus stop and doing 1 divided by 4. Top divided by bottom, numerator divided by denominator. So that's fractions into decimals. Let's look quickly at decimals to fractions. This is a bit easier, because if we put the hats on, units column comes before the decimal point, and then the tenths column. And you've got an 8 in the tenths column, so it's 8/10. It's actually a bit easier, isn't it? Next one, 0.75. What have we got here? Well, the units column is empty. You've got tenths, 7 of them, and you've got hundredths, 5 of them. How you would say this, how you would write this as a fraction, we've been doing this in morning maths lately, you've got 75 hundredths. So it's 75 hundredths. Another one of those, let's do a longer one. It's not necessarily bigger, in fact the number's not bigger than the last one, but it has more decimal places. 0.437. We have units, decimal point, tenths, we have hundredths and thousandths. You go to the last column that you've got, 437 thousandths. That's what their decimal is, 437 thousandths. So it's not too hard to turn decimals into fractions. It's usually, if you turn it directly into a fraction without simplifying or anything, it's always going to be tenths, hundredths or thousandths. Next bit, decimals to mixed numbers. So a mixed number looks like this. You've got, that's a decimal number. Mixed number is going to be the answer. 2 whole ones, and then what have you got? Well, units, you've got tenths and hundredths. This is pretty easy as well because it's 47 hundredths. You've got 2 and 47 hundredths. The 2 stays the same. The 2 was the whole number because you had 2 and a bit. We've still got 2 and a bit. This is called a mixed number, isn't it? Decimal changed into mixed number. Okay? Let's do another one. So you had 19, that's the whole number, 0.642. 19.642, well the 19 stays the same as we do a mixed number. We need a fraction on the end of that, so I'll put my hats on, units, and then we get tenths, hundredths, and thousandths. I'm going to go to the last column that I've got, which is thousandths, and say 642 thousandths. 642 thousandths. So 19.642, 19 and a bit becomes 19 and 642 thousandths. That's decimals to mixed numbers. Finally, mixed numbers to decimals. 1 and 2/5. Let's turn it into a decimal. Well, the whole number's the same, it's 1 point something. Now how would I change 2/5 into a decimal? I would do what I was doing a little while ago. This is how you turn a fraction into a decimal. 2 divided by 5, that's what it is. 2/5 is 2 divided by 5, isn't it? 2 divided by 5. Won't work unless you put 0.0 or 0.00 on. I think you only need 1 0 on this one. Let's see what happens. 5 into 2 is 0, carry the 2. 5 into 20 is 4, and no remainder. So it's 0.4, which is the same as 0.40. But we didn't need the extra decimal place, 0.4. So we have 1, and then the 2/5 is worth 0.4. 1 plus 0.4 is 1.4. Okay? That was mixed number, because it's a mixture of a whole number and a fraction, into a decimal. Mixed number into a decimal. I'll do one more while I'm here, shall I? Let's do 2 in yellow. 2 and 7/10. 2 and 7/10. This one's easier. 2 whole ones. You might know that, sorry, let's try and put a decimal point on the line. You might know that the tenths is the next column after the decimal point, and it's 7/10, so it's just 2.7. Let's just prove that 7 divided by 10 is 0.7. 7 divided by 10. Oh, I wouldn't really do this with the bus stop, would I? This is moving method. 7 divided by 10. I've been doing this in morning maths lately. 7 divided by 10 is a decimal point, very big. One place smaller, 0.7. Okay? So 7/10 is worth 0.7, and you've got 2, so you've got 2.7. And that is mixed number into decimal. Right, nearly there, nearly there. The last thing I think is measures. Someone's asked for measures, help on measures. And one of the first things is knowing how many millimetres in a centimetre, how many centimetres in a metre, how many grams in a kilogram, that kind of thing. So what I would say is, you know your 30 centimetre rulers you have, or any ruler to be honest, what has it got on it? It's got on it centimetres, it's got centimetres on it, 0, 1, 2, 3, 4, 5, 6, 7. It also has on it millimetres, these tiny, tiny little bits. Tiny, tiny, tiny little millimetres. So that's all that's on a ruler, centimetres and millimetres. And what I say is, if it's on your ruler, it's not 1,000. Some things are out of 1,000 in this. Most things. If it's on your ruler, it's not 1,000. So millimetres in a centimetre, it's not 1,000. There's 10 of those tiny little marks in 1 centimetre. So 10 millimetres is 1 centimetre. How many centimetres in a metre? Well, centimetres are also on your ruler, so it's not 1,000. It's actually 100. There's 100 centimetres in a metre. Okay? So you need to kind of learn those ones, but you can actually look on your ruler if you forget, because you can look on your ruler and see that inside a centimetre there's 10 little millimetres. You can't see 100 centimetres on your ruler, but you just have to learn that 100 centimetres is a metre. So if it's on your ruler, it's not 1,000, it's something else. Everything else is 1,000. So I'll show you that. Metres into kilometres is 1,000. There's 1,000 metres in a kilometre. Because it's not on your ruler. There's no metres on your ruler, there's no kilometres on your ruler. So it's 1,000. Next one, millilitres, that measures the amount of liquid you've got. So the amount of water or something like that. Millilitres into litres, that is also 1,000. It's not on your ruler, it's 1,000. There's 1,000 millilitres in a litre. And finally, grams and kilograms. Again, there's no grams on your ruler. This is used to measure mass, how much something weighs, you might say. It's used to measure mass. And again, 1,000 grams equals 1 kilogram. So I always say to people, just remember, if it's on your ruler, it's not 1,000. All the others, which are down here, all the others are 1,000. Sorry about the noise outside. Hopefully you can still hear me anyway. It's getting busy at school these days. So, that's the tip. If it's on your ruler, it's not 1,000. That was the top two. If it is on your ruler, it's 1,000. Oh, I've said that wrong, haven't I? Ignore that. If it's on your ruler, it's not 1,000. If it's not on your ruler, it is 1,000. Sorry, I'm getting put off worrying about the noise when I should be worrying about you guys listening to my video. Let's carry on. Last thing is to show you that you can practice your teaching measures on a website. Before I show you that, let's just give you an example of these things that are 1,000, like, for example, millilitres into litres. So say you've got 1,000 millilitres, you're going to have 1 litre, okay? Which means if you have 2,000 millilitres, you're going to have 2 litres. If you have 2,500, however many thousands you've got is your whole litres. So you've got 2 whole litres, because you've got 2,000, just like we had above, but you've also got 500. So you haven't quite got just 2 litres, you've got 2 and a bit litres, 2.5. You keep the 2 and the 5 next to each other, they just have a decimal point. Let's just move that up, do a couple more examples before I show you the last website to practice on. Let's say you had 3,740 millilitres. just check the thousands. 3,740 is 3. 3 in the thousands column, that's supposed to be an L, means you've got 3 and a bit litres. 3 and a bit, 3.740, or just 3.74. So you don't need that 0. You could have it, you don't need it. And follow this pattern, you know, if you've got 7,896 millilitres, 7,000 millilitres means you've got 7 whole litres. And the rest is 896.896. Lots of practice needed. That's why we'll have a look at the Teaching Measures website. This is very similar to Teaching Time. If your parents allow you to, you go on Google, you type Teaching Measures, first thing that comes up. Again, you could buy it, but you don't need to because you can evaluate it. They're quite happy for you to evaluate it to see if you like it. I like this measure match game. I was just doing capacity, which is millilitres to litres. It doesn't matter which one I play. Go to page 3 of this, and I like playing measure match. Very similar to what we were doing with time a little while ago. I've got to turn these litres into millilitres. Okay, let's try and find an easy one without decimals first. So 2 litres. 1 litre is 1,000 millilitres, so 2 litres is 2,000 millilitres. Where's another one? 4 litres. That's going to be 4,000 millilitres. 9 litres, 9,000 millilitres. If you play this a bit, you'll be amazed how much quicker you get. The rest have got decimals in. So 1.25 litres is 1,000 millilitres and a 2 and a 5. What have we got? 1,000. See how you still got the 2 and a 5? 1,250 millilitres. 2.75 litres here. That's 2,000 millilitres and a 7 and a 5. 2,750. You'll see how the numbers match up. 4.2. 4,000 millilitres, it's actually 4,200, and you keep matching them up like that. Let's do this one first. When you've got no whole litres, it means you've got less than 1,000. 0.4 is going to match up with 400, and 0.1 is going to match up with 100. You press check, the timer still goes while you get to the top, but then you can see again on this what time you can get. It made a buzzer sound because I didn't beat the 0 minutes 45 seconds. So see if you can beat 45 seconds and then see if you can get down to whatever, 15 seconds or what some people can get to in the end. Practice makes perfect on this math stuff, so I encourage you to practice your teaching measures. Anyway, measures was the last thing that someone asked about, so I've dealt with everything I've been asked about as far as I know. Thank you for listening, and I'll see you again.